The next piece we want to look at is how we convert entire equations from polar to rectangular or rectangular to polar. And for these, we're going to do a simple substitution. We are simply going to replace x with r cosine theta and y with r sine theta. Seems pretty straightforward, and it is. But the issue we're going to run into is all the algebra that comes up and simplifying. So that's probably going to be your biggest obstacle. The plugging in is going to be simple. It's going to be getting down to your final answer. Is that going to be what we wanted? So looking at the first one, x squared plus y squared is equal to 4. We know that's a circle with radius of 2. So if I think about in terms of polar coordinates, I'm going to want all points that have a radius of 2. So somewhere in there, a 2 is going to need to come up with my radius. So let's see what happens when I do some substitution. I know x is going to be the same thing as r cosine of theta. So r cosine of theta squared. Y is the same thing as r sine of theta squared is equal to 4. So now if we're squaring a quantity, that means each piece inside the quantity is squared. So r squared cosine squared of theta, and then r squared sine squared of theta is equal to 4. And when I look at that on the left-hand side, I can factor out an r squared. So r squared cosine squared of theta plus sine squared of theta is equal to 4. I know cosine squared plus sine squared is equal to 1. That's an identity we learned back in chapter 4. So really, I've got r squared is equal to 4. Take the square root to both sides, and r is equal to 2. Now here I technically could say that r is plus or minus 2. When I graph those, we'll see that that's actually the exact same picture, just a different direction we're going. But since we're talking about distance with a radius, we can deal with that positive piece. The second one, x equals 6. Well, x equals 6 we know is going to be a vertical line. But what does that look like in polar coordinates? So we know x is the same thing as r cosine of theta is equal to 6. And from that point, we can divide both sides by cosine of theta. So r is 6 over the cosine of theta. And we don't like our final answer having that cosine in the denominator. We know that this is technically 6 times 1 over the cosine of theta if I split that up into two separate fractions. And 1 over the cosine of theta is the same thing as secant of theta. Now before we move any further, let's take a quick look at plugging these into our calculator to see, does this make sense? Now if I pull up my calculator and I go to y equals, I've got my y1 and my y2, y3s, and that's rectangular form. And if I were to plug in x squared plus y squared is equal to 4 into this calculator, what I would need to do is I would need to get y by itself and then put the positive version in y1 and negative version in y2. So if I were going to plug this into my calculator, I would have to say y equals plus or minus the square root of 4 minus x squared. So in the first one, I would plug in the square root of 4 minus x squared. And then in the second one, I plug in negative square root of 4 minus x squared. I go to my zoom, and we'll go to, you could do zoom standard. And I'll see my circle that I get. Now you might say, well, that looks like an ellipse. Reason for that is the fact that my x scale is not the same as my y scale in terms of pixels on the screen. If I want to change that, I can go to zoom square, and I can see it looks more like a circle now. So there's my circle. But if I wanted to graph that in polar coordinates, I've got to change my mode. So the mode we can see option number 4, functional, parametric, polar, or sequential. We're going to choose polar. Oops, I need to choose polar when I do that. There's polar. And now if I go to y equals, I see my y's are now r's. So I can plug in r equals 2. Let me go back to my standard view for that. And there is my circle that I would get in polar coordinates with a radius of 2. Once again, you can see that that picture is slightly oblong because the x tick marks are further apart than the y tick marks when I look at the screen. If I look at my second example here, x equals 6, I know x equals 6 is a vertical line at 6. So let's confirm if r equals the secant of theta is a vertical line at 6. And we've actually got to put in that 6 divided by cosine of theta, since we don't have a secant function built in. If I hit graph, and sure enough, there's my vertical line at x equals 6. Same thing as r equals the secant of theta. And actually this is 6 times the secant of theta. Forgot to put that there originally. So 6 units out and I get the secant of theta. So you can graph these pieces in polar coordinates by converting to polar form and then looking back at what you know about rectangular coordinates in order to confirm if your equations are correct.